Hey everybody, I'm going to do another another data structure. And in this case, I am going to be doing a linked list. So let's create a new file, linked, I'll just call it link.js. Okay, and then I'm going to clear my terminal. Okay, and what a linked is actually we have to create two classes. One for an individual node. So an individual node is one piece of data. So basically the difference between a linked list and your standard array is that generally, if we think about it like in your computer's memory, you have like spots. So think of like as little cubby holes. So an array, a traditional sort of standard pure array, is a sequential sort of set of spots in your memory. So in that case, what happens is that when I create an array in sort of a lower level language, it sets aside that exact, I have to specify I want an array of 5 strings, right? So then it's going to set aside the exact amount of memory it needs for 5 strings, and those are congruent spots in memory. Problem is I can't expand it because that particular memory has been set aside. Other things may have been put in the memory spots right afterwards. And some stuff might exist in the memory spots right before it. So all I have are 5 spots for 5 strings in this array. But the benefit is, since they're congruent to each other, it's quicker to traverse, and I'm not worried about memory just kind of running away with me. Okay, so if you've ever worked with like C, C++, or Java, where basically you generally have fixed arrays, and adding and subtracting things from arrays are a little bit more difficult than, let's say, JavaScript, where arrays are like much more dynamic. That's what's going on. So a linked list, which I would assume that it's probably a linked list, what's going on under the hood in an array of JavaScript, is that in a linked list, you're not having congruent spots of memory. Instead, what you do is you have a spot of memory with one piece of information, and the linked list is keeping track of these different spots, these nodes. And so the linked list is really, in each node has an address for the next node. So each node keeps track of what the next node is. And so the way you traverse the data is that you have to go to one node. That one node has the information, and then has for it, where it came from and where it's going, and then also has its own data. Okay, and then you would have to traverse it by saying, okay, let me go to this node. The next node is this, so let me go to that one, and you kind of follow like these chain of breadcrumbs to the particular node that you want. Okay. So in that case, let me think, do I really need to... Yeah, I still want... I'm still going to use 2 classes just to... So first we'll create the node. So class node. Okay, and essentially a node is going to have 3 pieces of data. Okay, it's going to have the data. Okay, which will initialize as null. It's going to have the prior. So this is like the prior node. Okay, so in like C++, this would probably be a pointer to where the previous and next node are. JavaScript by default just does objects as references, so it'll essentially be the same thing. Prior and next equals null. So right initially these things are all null. Okay, and then what's going to happen is constructor. Okay, and the constructor will give us the prior, so the previous node, and data. Okay, prior and data. Okay. And this is, and generally I'd probably want to make all these node properties protected normally. Again, I forget if JavaScript you can do that. I don't think you can do protected methods in JavaScript, if I remember correctly. Everything's public. I think, yeah, you have private, but I'm not gonna stress out too much about that. So in the constructor, what I am going to do is that this dot prior, so this would be the prior node, equals prior, and then this dot data equals data. Okay, so there's the node. Okay, and then we want to access the prior, so we'll do a prior method. So if you want to go back to a node, so prior will just return prior. Okay, or this dot prior. Okay, and then basically add node, or we'll call it append. So we're going to add a node. Append node, we add the new node. Okay, and in the new node, what we're going to do is we are just going to take this dot next, and that's going to equal the new node. And the last thing I want to do is have a next method that returns this dot next. Well, actually, first let me do it this way. Return, no, let's say if this dot next, so if next is still null, I'll do something else, then return this dot next, else console.log, there's no next node. Okay, cool. So here we go. We have all these nodes. Now we're going to create the actual linked list structure. That'll actually kind of be an abstraction over this node class. Linked list. Okay. And what this is going to have, it's going to have a member called current, which will start out as null. And then it's going to have a array of nodes. Actually, it doesn't even need that because they're all linked to each other. So current. So then what happens is we will do this constructor. Okay, the initial piece of data. Okay, and then what we're going to do is we're going to say that this dot current equals, and actually that means I should probably do the same thing here with prior. So Control C. If this dot prior, make sure that in case you're going, because you can't go back from the very first one. No prior node. There we go. Save. Cool. This dot current. Okay, it's going to equal a new node, and the new node's prior element is null, and the initial data will be initial. Let me just make sure that is the right argument. Yeah, prior data. Cool. Okay. Did I get? Oh, I need to actually add a method to get the data. Data. Return this dot data. Okay. Cool. So then in this case, we'll have a method to get current, which will be basically returning this dot current, which would be a node dot, what did we call it, data. Okay, then we want to add node. So we're going to say data. Okay, and then append, yeah, new node. Well, actually, it should be data. Okay, which would be then a new node. This is the prior node, and the data is that. Cool. Okay, so again, when the constructor is initialized, so let's think through this. We want to get the current node, so get the data from the current node. We want to add a node, which will take the data, and we'll take this. Let me just think about how this is. What does this return? Just .next. Okay, add node. So this I would just take this dot current. Actually, you shouldn't add it to the current because you may not necessarily be at the end. So we would want to do. So in this situation, you probably do need an array of nodes. So let's do that. Let's add nodes equals an array. So then, and then again on nodes, we will push this current node. Good. And then what we're going to do is we're going to say, we're going to say this dot nodes, this dot length. I mean this dot nodes dot nodes dot length -1, and let me just say this dot here, this dot nodes length -1 dot, because we're accessing the very final node because that's what we're appending it to. Append data. Okay, so that'll create a new node. And then we should return the new node. Return append. Return this dot next. Because then we need to add that to the array. Okay, so this dot current, get current, this node, and then this is going to be like this dot nodes dot push. There we go. So basically what we're doing is we're adding a node to the very last element and adding that to the array of nodes, so that way if you continue to add items, yeah, they're there. Cool. Now here we're getting the data of the current one. And now we just need a function to go back and forward. So next will be this dot current will equal this dot current dot next. Let me just double check that that's how that works. Yeah, return this dot next. That is fine. And then this will become prior. So we can go back and forth and traverse the linked list. Okay, and I think that should work. So if I say const my list equals new linked list, and we start off with the number 1. Okay. Then first let's add a bunch of items. So let's say my list dot add node 2. Three, 4, 5. Okay, my current node should still be the first one. So if I do console.log my list dot get current. Make sure am I returning the. So I'm getting the data from the current node. Okay, and then we'll keep going next. So my list dot next. Let's do this a few times so we can see us traverse the nodes. 1, 2, 3, 4, 5. So let's run that code. Node linked list. And there it goes. Yeah, it worked. Okay, so you see we added the data. Then I would get current node, which console logs 1. Then go next and go to the next node, which is 2. Then to the next node, which is 3, 4, 5. And then when I hit the last one, which didn't have a prior node, it just console log no next node because I hit next too many times. Okay, so yeah, we made a successful linked list. Yay! Okay, I'll see you guys in the next video. Ciao.